So I got about 20 minutes for the next meeting now. I decided not to eat lunch, so I just took a small break and came back. And I'll do these. These are a little bit rougher than some ones in the front, but they're actually not that bad. The easiest way to do 36, since they're both x's, is to probably convert both the top and the bottom into exponential form. So the top would become x to the 6/4 because the power is 6, root is 4. The bottom would be x to the 5/7. Now, what you can do is you're going to subtract 5/7 from 6/4. That's what you're going to do. You're going to take 6/4, which is 3/2, and you're going to take away your 5/7 back as a fraction, 11/14. This becomes x to the 11/14. Now this thing started as a radical. Your answer is supposed to be a radical. This is the 14th root of x to the 11th power. Ta-da! There is another way to get to it, but I've tried teaching it in the past and kids just did not like it. So that's the easiest way to get the correct answer. It's actually harder to do it if you stay with radicals. I don't even want to show you what it looks like. These are like terms. 3/4 minus 1/4, that's what, a half? Yeah, it's 2/4, it's a half. It's 1/2 y to the 3/2. They were both like simple. 38, I personally would realize that those are not like terms, but they might be. See what happens when I move this 2 in. This piece becomes x squared y to the 1/2. That's nice. Ooh, looky. This becomes x squared y to the 1/2. So I have x squared y to the 1/2 plus another x squared y to the 1/2, which is obviously, if you understand math, 2 x squareds y to the 1/2 power. Obviously. All right, 39. Get over there. Let's see here. It's not like terms yet, but it will be. Remember the understood 2 on your square root symbols? We have an x. The square root of 9 is a 3. 2 enters 3 one time with one piece remaining. So this first piece, this first term, becomes 3x squared root x. Take away 2. 2 enters 5 twice, so that's an x squared root x. And now we have like terms. 3 minus 2 is 1. This is x squared root x. 40. We have a plus sign in between. Let's see here. One of these is messed up. I wonder if I ever fixed it. Think about the 4th root of 32. What I think about is 16 times 2, which becomes 2 4th roots of 2. All right, so there's going to be a 2 involved. I have a y. The 4th root of x to the 6, 4 enters 6 one time with 2 pieces remaining. So the leading term becomes 2yx, 4th roots of x squared. This guy right here, when I look at 162, what I think is 81 times 2, and the 4th root of 81 is 3. So I'm thinking 3 4th roots 2. So I got a 3 involved. I'm going to leave a little space here. 4th root, there's still a 2 on the interior. 4 will not enter 2 on the x squared, so the x squared is still trapped there. 4 will enter the y piece one time. And that is really about as good as it gets. So not much else you can do with 40. 41, you have x to the 5 root 3 over x to the 2 root 3. And what you do is you subtract exponents. 5 root 3 minus 2 root 3 is obviously 3 root 3. I say that sarcastically. A lot of kids just don't see it. I wish you did, but they're like terms. 42's got some pi in it. Who doesn't like pi? Anyways, I'm going to distribute that 2. Then I'm going to do my subtraction. Two pi minus 2 pi over 3 is going to be 4 pi over 3. I know you may not see that, but I swear I'm right. If I do 2 minus 2 over 3, and I'm just doing the T84 just to show you that I'm right. It's 4/3. And what's up with this funny looking thing? Oh, those are like terms. They are. There's just 3 of them in the second grouping. So now there's 4 of them. Who cares if it looks funny? Same rules apply. And that finishes it for all the exponential part of this homework assignment, I think. What's up next? Probably a time for a new video because this is like function composition and some graphing stuff. So anyways, stop this video, start a new one. Be right back after these messages.